So, this HDTV project is obviously about HDTVs, and it's really about determining what size TV and where you should hang it in your given room. So let's say you move into a new house, you have a living room, and you want to determine, because you can only sit so close or so far depending on the room, right?
Savior, we're Gen Z. You think we're going to own houses?
Well, pretend. Your apartment wherever you are, right? So listen, or maybe, guys, please, maybe you're putting one in your bedroom. You should not, depending on the size of your bedroom, if you have a ginormous TV screen but you can't sit far enough back, it's actually not going to be that good of a quality. You need to be sitting within a certain range to have the best viewing experience you can. So, guys, if you take a look at this chart here, so this was taken from choosing screen size and placing your TV from this website right here, okay? So, according to this person, guys, are you listening at all? God. So, anyway, here's a nice chart that they have come up with. This is the screen size that you should have depending on how far away from your screen you're going to sit, okay? So, if your bedroom is only, I don't know, at the longest, 10, I don't know, let's say it's, I don't know.
10 by 8.
Say it's 10 feet long and that's the most space you have, well, maybe you shouldn't be getting 58, 65, 70-inch TVs because you're going to be sitting too close and it's not going to look very good, okay? So for each of the TVs, you want to be sitting in a certain range to have the best viewing experience, yeah.
Well, so I'm considering buying a TV, so is there any chance, is this, legitimate information?
Yes!
I have a 72-inch screen, but I'm getting the TV for my dorm.
Well, you're not having the best viewing experience then.
I have to move my neck.
How do movie theaters work then?
They have it bracket on the ceiling.
All right, guys. So, feel free to read the information about the article here, but it's basically what I just told you. And it's not just how far away from the screen you're going to be, it's also where are you placing it on your wall. Okay, so we're going to have two scenarios. In the first scenario, your eye is in line with the bottom of the screen. So this is the TV right here. So it's as if we're looking at a side profile. Okay, right. Well, oh, okay, wall. But this is, here's your TV.
On the wall.
Floor to ceiling television.
No, hold on. What's going on here?
What's the matter?
Everyone's
You have the TV hanging on the wall, right?
Is that whole line from the top to the bottom the length of the TV? No,
It's the height of the TV.
So why is there eye at the bottom? Why is there eye at the bottom of the wall?
No, it's not. This isn't the entire wall. This is the TV on the wall. That's all.
Top of the TV, bottom of the TV, and you're looking at the bottom of the TV. Okay, so the wall is 18.5. I mean, the TV is...
The TV, right. So if we read this little blurb right here. Guys, please stop talking. So, questions refer to an advertised. So these questions are going to be specifically on a 37-inch diagonal flat screen HD TV. Remember, if you're talking about TVs and it's 37 inches, it's this, like if I'm looking at it straight on, it's the diagonal that's 37 inches, right? So they're saying the height is 18.5 and the width of the TV screen is 32.5. In these diagrams, what you're looking at is you're just looking at the side profile, right? So it's hanging on the wall, so all I see is just this piece, right?
The hypotenuse right down here is 37 inches.
No, I have no idea what it is.
Well, that's why it's called
These are
X.
different views. This is
But,
viewing it right from the front, and this is the side.
okay.
We just need to find out how far back we are.
Basically, so that's your initial scenario. Let's say you wanted to hang your TV so that your eye is level with the bottom, okay? So what you're going to be doing, if you look at, so this is scenario 1.
Yes.
And this is, I don't know why, but this seems to confuse kids every time. So scenario 1 deals with figure 1. I know that figure 2 is on the same page, but it has nothing to do with scenario 1. You're using figure 1. Everywhere is noted figure 1. So make sure when you're doing your work for scenario 1, you're looking at this picture.
Scenario one together.
No! But we're going to read it and I'll help you figure it out. So, scenario 1. Suppose that the HDTV is mounted on a wall so that the bottom of the screen display is located at eye level, just like in figure 1. As the viewer moves closer to or farther away from the wall, the viewing angle will vary, right? So, if you were to move closer and you were here, your viewing angle would be much bigger. If you were to back up, right, your viewing angle would be smaller. So we want to make sure that you are in the best possible position. So here's what you are to do. You are going to write a function that gives the viewing angle, theta of x, measured in degrees, in terms of the viewer's distance from the wall. Specify the domain of the function. Don't worry about this just yet. In order to help you with this, let's just go back to a question, I don't know. Let's pretend we had something like this, and this was 3 and this was 4. Oh, sorry. Lauren, will you shut the lights off, please? How would you solve this question? It is, but I don't need that. I'm looking for theta. Oh, wait. I take that back. It's not 30, 60, 90. It's a Pythagorean triple, though. Right. But that doesn't tell me what this is.
Start making a box in 4/3.
I'd make a box out.
Andrew, say it louder. Tangent. Oh, right. Tangent.
Oh, not
Opposite over adjacent. What?
How'd you get 4 and 3?
I'm making it up. I'm doing a sample problem to help you remember how to do this. So tangent of theta would just equal 4 divided by 3, right?
Right.
And if I wanted to solve for that angle, how would I do that? Right. So here's how you write that. On our calculators, we know we hit second tan 4 divided by 3. When you're writing that on paper, it looks like this. You would do theta equals tangent to the negative 1 power. That's how you show inverse tangent.
Right.
Bless you. So the first problem, scenario 1, the first answer, looks exactly like this, except that you have 2 variables. You'll have a theta and you have an x in there, because you don't have both of these values, you only have one of them. So your answer, again, will look exactly like this. You will just have different numbers, right? Because I'm not using a 4 and a 3 in figure 1. And you are going to have an x in your answer, okay? Now, let's talk about that domain piece, right? If you have a variable in your denominator, you are restricted as to what that variable could equal. So for example, if I had 1 over x minus 2.
Oh, it can't be a negative number.
Well, it can't be... What am I never allowed to have in the denominator? A 0. So in this
X
case,
is the element of all real numbers except for 2.
right, x cannot be 2 here.
I think I just found the answer.
That's my domain. X can be anything it wants as long as it's not 2.
That's the answer.
Well, for the domain of this, yes.
Okay.
If you had something like this, say you had, I don't know, 6 over, 3x minus 5. X could be anything except for
Whatever 3
A little less than 2.
5 divided by 3.
yes, 5/3.
Oh, yeah.
I'm so smart, Miss Adrian.
A little
Okay.
That is a little less than 2.
I'm
If
gonna
you're
do
not
that.
paying attention to me now, don't expect me to answer questions for you later.
Louis, how do you want to do
Just saying. Yes, you're going to have to go back to the video. Because I won't be answering questions if you're not paying attention to me now. You're going to have to refer to it. So I hope every question you have I answer in this. All right. So anyway, you are just going to tell me what the domain is of whatever your equation looks like here. So whatever, you can have x be whatever number as long as there is no 0 in the denominator. So here, I mean, I don't have an x, so it doesn't really apply. But if you had something like this in there instead, you would say, oh, x just can't be 2. X just has to be, I can't have a 0 in my denominator. So x could be anything else besides whatever makes it turn into a 0 in the denominator. So figure, scenario 1, I have basically walked you through exactly what you need to do.
Well, then how do we get to X?
Well, that's part 2. So, in part 1, ladies, gentlemen, oh my God, why am I even trying? It's all explained right here. You don't need me, so I don't need to be doing this. Because all the instructions are right here. So maybe I should just stop now and leave you to it. The second part, you're going to get your answer from the first part. There's going to be an x in your equation. In the second part, you are plugging in these two values for x. And for whatever reason, sometimes students don't seem to understand that you need to do two separate problems. One time you're going to plug in 4.63, and one time you're going to plug in 7.71. So there's two separate things that you need to be showing me here. So one time show me for 4.63 feet. So all you're doing is plugging 4.63 into the equation you came up with in, right, and you get an answer. Then you're going to do it again for 7.71. You're going to get an answer. It tells you round your answers to the nearest tenth of a degree. So this is assuming, right, he's saying, the person that wrote this article says, for this size TV, you should be sitting between 4.63 and 7.71 feet away from the screen. So you're going to calculate it at 4.63, see what your viewing angle is, and you
37, because that's like right on the front page, 4.63.
You're not solving for the size of the TV. You're solving for the angle that you're going to be viewing it at. Yeah.
Hey, thanks, bro.
Okay. So you're going to get your two answers there. All right. And then that's pretty much it for scenario 1. Scenario 2. Now, instead of mounting the TV at eye level, we're going to mount it up a little bit. So here's the entire wall, and my TV is now here, and my eye is still down here. So it's no longer at eye level, it's up. So I know for me at home, this is my scenario, right? Because I have one of the TVs over the fireplace. So, yes, it's very nice. So you have it up here. So, this one, you'll notice theta is only this angle. Again, I'm going to be trying to find just this angle. However, this is not a right triangle. So, can someone kind of tell me how I could find this angle? Someone, I think, said the right answer, and if I'm just assuming it was out there. Couldn't I find this whole big angle? Right. I thought you were saying that, Griffin. If I find the whole big angle, and then I find this angle, which that's a, well, it's an alpha, the Greek letter alpha. So so here's, guys, what you might want to do is just refer to this, I don't know, I'll call it the big angle. And then I have another angle, alpha, here. So if I take the big angle and I subtract from it this alpha angle, I'll be left with theta.
How do you find alpha equal?
Well, look at what you have.
Got it.
Right? So if I'm just trying to find alpha, I'm going to have another equation with an x in it, and that's okay. Right? So I'm going to set it up. I'm going to figure out what alpha is. Alpha is going to be equal to blah, 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 blah. And there'll be an x in it, and that's okay.
How do you set it up and find out?
The exact same way you did This one.
Yeah, man.
Miss Xavier, how would you find x in inches though if you need to take tangent of?
You're not solving for x. You're going to be plugging in for x in the next part. You're not solving for x right now.
Yeah, no, I was just, in like scenario 1, I was just going back and looking at it, and it would be.
Are you guys coming back to that? Yeah. Well, if you do, I'll see you then. Thanks.
It'd be like tangent of theta equals 18.5 over x, right? And then you take inverse, how do you take the inverse tangent of 18.5 over x on the textbook?
Second tan. Oh, you don't. You're not solving. You're not. Right. You're gonna leave your answer with an x in it for part 1. And then in the second piece of part 1, you're plugging in those two values for x. Yeah. Sure. Huh?
So then what would the domain of scenario 1?
She's back.
I forgot something.
Ooh, thanks. Thank
Calling your tab, Mrs. Xavier.
You guys could pay it for me. That'd be awesome.
I will.
Pay it right now.
If we pay it,
there's no fine.
Oh, yeah.
Well, you should know how much I owe. Oh, I still have $2, so.
How much do you owe?
Well, if I
add
continue
money
to
to
get a
that.
coffee every Tuesday and Thursday until the end of the year, I only have enough for one more week.
Oh, no.
I'm kidding. It's fine.
Well, I'll give you $5.
Don't worry, I got
and
this.
you
What
buy
was the domain?
It's all right.
the rest of the year, and then
You
I'll-
gotta ask yourself, what would make the domain turn into a 0? Like here, it could be anything except for a 2.
Anything except 0.
That's what I said.
Okay.
All right, so we're on scenario 2. So we were talking about this. Scenario 2, you have the TV up higher. We're still worried about theta, but the only way to find theta is to find this big angle. So you're going to set up an equation to find the big angle, just like you did in part 1, using the big triangle. And then you're going to have an equation to find alpha, this angle. And then, didn't you just say that you were going to take the big one minus alpha, and that would leave you with theta? That's exactly what you're doing. So, in step 3 here, you're just setting up that equation, the big angle minus the little angle, and that'll leave you, so even I'll write it. So figure out an expression for the big angle. Oh wait, big angle. Whatever that expression is, it'll still have an x in it, that's fine. It'll have an inverse tangent in it, that's fine. You're gonna minus the little angle, which is alpha. And what's left over will be theta. Okay? So now you're going to have an expression for theta. It'll still have an x in it. Well, more than one x in it, actually, because you're going to have an x in each one of these. Huh? Well, but when you're going to take just this piece, right? So now you're going to bring that down here, and now again you're going to plug in 4.63, and you're going to plug in 7.71. So you're going to do that 2 separate times. So you're going to show me, excuse me, 4.63.
Make 2 equations and then plug in the same thing.
Well, you have one expression. You're going to plug in 4.63 for x in one of them, and then you're going to do the same thing. Right, 7.71. Okay, you're going to get your answer for each one of these. And then you're going to answer the question. Don't forget to answer the question here, because this one has a little bit more to it. It says, how do the viewing angles from the minimum and maximum recommended viewing distances in scenario 2 compare with those in scenario 1? So I want you to compare your answers here with your answers that you got here.
Oh, so we plug in the same numbers?
Right, right, right. So let's assume you only have so much, right? You only have so much room, like you can only sit so far back in a room before you hit the wall, right? So we're assuming in this scenario, I have a 37-inch TV, right? Where should I be sitting? Should I be hanging it so that it's level with my eye? Or is it going to be better if I raise it up higher? assuming that I'm sitting between 4.63 feet and 7.71 feet away from it.
So this doesn't even ask a question
Yeah.
of what if
You
bad
have a-
vision or action.
Yeah. All my seats recline in my living room. I made sure of that.
So the seat does the work for you.
Yes,
Opposite of the neck held up with the back.
correct. It's lovely. So, that's it.
What's it like looking like a big shot rich person?
Does anybody have any questions that you need me to answer right now?
I'm sorry, can you
Do you
just
have
review,
like seats?
I'm sorry, can you just review the last thing you said about the question?
Just make sure you answer it.
I think I have the wrong equation.
I can check it for you. But the last question, it just asked you to compare your answers for scenario 2 with your answers for scenario 1. Okay? All right, so that is your project.